All right. Good morning, everybody. Welcome to the October 10th, 2025 working group meeting. We will start off with some new membership today. And today on our list, we have Phyllis McCallum from the Canadian Agricultural Human Resource Council. Phyllis, would you mind just giving yourself a quick introduction to the group and what brings you here?
Sure, absolutely. Good morning, everyone. Thanks so much for letting me join your group. My name is Phyllis McCollum, and I am the Senior Program Manager of Research and Knowledge Mobilization at the Canadian Agriculture Human Resource Council. In my role, I'm responsible for labor market information and our workforce strategy for agriculture and food and beverage manufacturing. If you don't know much about CARC, we are an HR provider for primary agriculture. And so a lot of our programs revolve around workforce strategies and helping with labor challenges in primary ag. I joined your group because much of the work that I'm doing now, especially with the workforce strategy, is pointing more and more towards the adoption of technology and innovation. And so I'm trying to get my hands in as many places as possible, learning what everyone is up to and what they're doing. And so I am a policy fellowship member with the U of G with the program they're running. And this group was recommended to me to join and hear what everyone's up to. So I think that's mostly it for me. I am double booked through this hour, so I will only be on for half an hour this morning, but I look forward to the conversations that we have in the meetings going forward.
Excellent. Thanks so much, Phyllis, and thanks for joining us this morning. That was everyone from our list. However, is there anybody here who hasn't had a chance to introduce themselves who would
Yeah.
like to?
So,
David, please go ahead.
yeah. Good morning, everyone. Thanks again for also inviting me to the working group. So I work for Waterloo Economic Development Corporation. We're basically the investment promotion agency for the Waterloo region. But my role specifically is for looking after the rural townships around Waterloo, and I have a lot of agricultural customers and businesses in that area. So just understanding what kinds of problems are out there, what kind of solutions can be brought to the table and be developed is interesting to me. So yeah, it's a better way to support my customers. I'm also the chair for the Bay Area Science and Engineering Fair, so I'm often working with youth that is developing different robotic solutions or different types of technology for the agri-food sector. So again, just getting better insight into what's happening helps me in that role supporting the students. So.
Excellent. Sounds great. Thanks so much for being here, David. Appreciate it. Was there anybody else? No? All right. Excellent. In that case, we can head on into our presentation for today. So today we are joined, I apologize if I get this wrong, Ezeh Ifesinachi, uh, from the University of Guelph. He's here today to tell us about the NIO Oreo robot weed management assessment that they did on muck and mineral soils. So Ezeh, please take it away.
All right, thank you, Dan. Let me share my screen. Can you see my screen there?
Uh, yes, we can. It's not in presentation mode. There we are.
Is it okay now?
Yep, you're all set.
All right, good morning, everybody. My name is Ifesinachi Nelson Ezeh. I'm a master's student with Dr. Mary Ruth McDonald at the Department of Plant Agriculture, University of Guelph. And I'll be giving updates on the trials that we had for this past 2 years on Nile Oreo robot uh, management of weeds in muck and mineral soil in the Holland Marsh, as well as also be talking about the pixel farming laser one weeding robot that we are also tried out this season. Before I proceed, I would like to appreciate the summer students and technicians that assisted me with this trial, as well as the Hegarity Agro Robotics for providing the robots that we used in this trial. So first, why robotics? Why did we decide to go through with this trial? For those of you that may be conversant with the whole and mash, this area and the growers in this region, they just don't have enough time or labor to stay on top of the weeding and spraying window. As a
Can you
result,
speak up just one more notch, please?
okay. Probably, oh, maybe it's the speaker. Okay. Yeah. So the project goal wanted to just answer the question why on how can we keep up with the weed control problems and when the resources available to the growers are stretched and the conditions are very, very unfavorable. So this led us to develop the goal, the objective to look at the Nile Oreo robot and compare its management, weed management efficiency to that of the tractor. Before I go on, I would like to introduce the Nile Oreo robot to some of us who may not be conversant with the robot. It is a fully electrical robot. That means it operates completely on, its drivetrain operates on battery, and which can go up to 10 hours a day and or 9 acres, or yeah, approximately 9 hectares, approximately 22 acres according to the manufacturer information. However, when we were in the field using this robot, we never experienced any power shutdowns. So for all the time that we used this robot in the field, it lasted through all our field operations. It also uses RTK and camera guided systems for its autonomous navigation. By autonomous, I mean it drives on its own. It doesn't require any driver to operate it once you've given it the instructions. So it has a 3-point hitch, which allows it to carry on different farm implements that may be available that the grower may already have. As for the safety system, it features LiDAR sensors, wheel bumpers, and a kind of geofencing that allows it to detect obstacles when it's during its operation. Another feature of this robot is that it can generate its own field map in real time, or you can have a pre-recorded RTK information and upload it into the robot, and it will still be able to work with that information. So for the study, for the trial, we had 2 fields, muck and mineral soil, and each of these fields we had 2 crops that we deployed the robot and the tractor, and we had the carrot and table beet in each of the fields. So the cultivators that we use for mechanical control were the rolling gang cultivator with spider spikes and the S-line cultivator. The difference between these two is just mainly in the depth at which they disturb the soil and the gauge. The rolling gang cultivator gets most of the weeds that are close enough to the rows, whereas the S-line had a narrower gauge. We used the S-line early on in the season because the configuration for the robot, we couldn't fit the rolling cultivator early on in the season. That needed some adjustment, and there was a little delay before we could get that on. For spraying, we had a band sprayer that with 2 55-gallon tanks, and 3D printed cones, like you can see on the picture here. These cones allow for like a precision herbicide delivery in between rows. And the 2 gallons or 2 tanks allow for delivery of 2 different herbicides at the same time. So for our spray routine, we had same routine for both the tractor and the robot. In the mock soil in table beats, we applied the product Betamix, and because we had there's more weed pressure in the mock soil, mechanical control started early on, immediately after the herbicide was applied. So for these mechanical control in table beat, for about a week, when we couldn't get the rolling cultivator gangs to be fitted in the robot, we had the S time. It was using the S time. However, this issue was resolved as soon as possible, and all the subsequent mechanical cultivations that were carried out later in the season and as well as in carrot fields were all done using the rolling cultivator gangs. So for the robot's uptime and downtime, we didn't see any differences in terms of time of operation between the tractor and the robot for weeding and spraying. This 50% mapping and lining that you see here, it's the robot that carried out the mapping for the whole entire field, including the plots for the tractor. So that's why it has more time doing that task. For downtime, most of the downtime came from charging, and the charging time was often at the end of the day. So this didn't interrupt any plan that we had, or the charging didn't interrupt any of the operations that we planned out. The troubleshooting came mainly from signal disruption in 2024 season, where there was a network outage for like about 2 days. So that's the 6% we see there. So to the effect of the treatments or management on weed biomass, from, like I mentioned earlier, because of the inability to get that implement earlier on, we see that there was a difference in the treatment in the mock soil for table beet. However, later on in the season, there was no difference between the tractor operations and that of the robot. On mineral soil, because we had the same tool earlier on, there were no differences. So carrot, no differences in terms of the weed biomass that were left behind in both soils. So the issue we experienced earlier on also kind of followed the same pattern. We see that in terms of yield, beet yield on mock soil, there was a difference. However, in mineral soil, there was no differences between the yield or in carrots. So for 2025 season, that's this year, the Oreo was out for like about 3 months, and it wasn't ready until like about middle of August. As a result, we weren't able to repeat our study and validate the results we got in 2024. So we set out to compare its herbicide application efficiency after the technical issue was resolved. So the trial was to just compare treated and untreated portions of the carrot field. So from this trial, we observed that the technical issue with the Oreo, despite it being operational, still was lingering as the robot stopped every 20 to 25 seconds. The precision cones that we had were constantly interfering with the carrot canopy, and its position was always constantly shifted. as well as herbicide drips from the edge of these cones were causing herbicide damage to the crops. We tried to switch the robot into different speeds and different spray mode to see if any of these issues that we're experiencing might be resolved. However, the problem still persisted and the trial was terminated. So we moved on to looking at the pixel farming laser one weeding machine. This machine uses CO2 lasers to target weeds, and it's more, according to manufacturer information, it's very efficient at when the weeds are still young at 2-leaf growth stage. So it has its own cooling system and modules for acquiring targets and deploying the laser beams. Before we started using this machine, first it's tractor mounted, and we took it out in the field to capture the image of the field where we will use it. So while in the field, we took over 600 images. These images were annotated and using its software and segmented into crops and weeds. So and re-uploaded into the memory of this machine. So that way it knows the field is going to work on, and it can be able to identify which is the crop and which is the weed. In concept, that was what we expected it was going to do. However, in the field, we saw a different thing. So while in motion, the laser was taking too long to acquire targets. And when it did acquire targets, it will either hit the bead or it will be shooting the lasers on mock soil. So the video here, this video I have on the left, I don't know if the video, so like we came to a stop to see if we were moving too fast for the laser and probably, but no, that was not the issue. As when we came to a stop, it was still taking too long for it. It was just shooting some lasers randomly. I don't know if the red dots are visible enough, but I should have zoomed that so you can see there are different lasers there. When we couldn't get it to, when it couldn't acquire targets over the field where we were, where we had planned to use it, we brought it to a different location where there is no crop, just weed, like you can see on this image to the left here, and tried to, and started the machine to see if it will zap the weeds. However, the problem persisted. It's completely ignored all the weeds around and was just burning. I don't know if you saw those flames. It was just burning the mock soil. So as a result, we also kind of terminated this trial early because we weren't getting any consistent, reliable results. So here, as you can see, these are some of the damages so we were targeting this weed right here. However, instead of targeting this weed, it was completely destroying the beets. So from our observations, we came to a conclusion that it takes too long for the module to be trained, despite having over 600 images that we annotated. It wasn't just enough for it to be able to acquire targets in the field and actually deploy lasers to do some weeding. So it required consistent speed. Since it was a tractor operated, that speed may vary during operation. From the pictures and images or the images that we took, we realized that there were a lot of light interference, and having a shaded area, we think would improve the image qualities and help better training of the model. So in summary, from our 2-year trial, we kind of, or we can say that the Oreo at this point produced a reliable comparison to that of the tractor, except for the differences we saw in table bits. The mechanical operation in 2025 limited most of the operations that we planned for the season. And despite it being operational towards the end of the season, there are still some glitches that remain to be resolved. At this point, we can say that the laser one is not yet field ready for any operations in the Holland Mash. So what are the next steps? What are the next steps or the next things we think should be done is that the Oreo needs a capable or reliable GPS connectivity for its operation. Due to the nature of the technical issue that knocked out the Oreo for about 3 months, we think it needs a better insulation system for its cable, and as well as a better adaptable hitch to allow it to carry on more implements. We also think that the hooded cones that we design needs improvement and adjustment to minimize herbicide drips, and as well as allow the Oreo to be able to use it at different growth stages of the crop. At this point, we think that the Oreo needs a full season to validate all these findings and measure ROIs and costs more comparably. So for the laser one, we think that instead of taking pictures of its own and then you get back to the field, you get back to the room and annotate the images, we think that a pre-installed weed identification program will be more suitable for the laser one prototype, as well as if it operates autonomously, that would also help its operation. So that is it from me. I would like to thank the staff of Ontario Crops Research Center in Bradford, the Hegarty Agro-Robotics grant, and all the technical team that helped us get the Oreo going, as well as everybody that provided funding for this study. Thank you for listening to me, and you can scan the QR code on my screen to read up the reports for 2024 season. Thank you, Dan.
Sorry, I was muted. Thank you so much. We appreciate it. We did have one. We'll open it up for questions. We did have one come in the chat. Which weed species did you encounter in these studies?
You're muted,
Oh,
Epix.
Okay. For the both soils, there are a variety of, I'll just give you the common ones that we encountered in the Holland Mash, the mineral soil and the muck soil. We encountered the red root pigweed, mostly not sedge. For the mineral soil, we have more of the thistles there, the lamb's quarters, the ragweeds. The list there are about 16 different species.
excellent.
I don't know if that answers, but these are the basic ones. So, there was a lot of porcelain in the muck soil as well.
Excellent. Does the laser one could have been installed on the Oreo to get autonomous driving?
So I can answer that
I'm
one if
not
you
sure.
want, Ifix.
Okay.
Like the idea is that it could have been. One of the limitations that we found after, because when the laser one was built, that's actually what it was for, was to go on the Oreo. Due to some of the mechanical problems that we had, going on the tractor is what we did. But one of the challenges that we discovered right away is the way that the Oreo is built for its minimum ground speed. It couldn't actually drive slow enough in autonomous mode to try to let the Pixel one or the Laser one work. And the motor controllers would draw like too many amps. And we did talk with NIO about trying to allow it to operate a little slower in the software, but it just didn't have enough torque to actually drive. So we couldn't do it.
Excellent. Thanks for jumping in there, Chuck. Were there any other questions?
I have one. Can you hear me? I'm driving.
Yes, we can hear you.
Yes, I don't know if you can hear me clearly. Well, thanks. First, thanks, Ifesinachi. Great presentation. I really enjoyed it. This is extremely useful information for me, and I think for a lot of people as well. Great research. I'm certainly going to be looking at your report soon. If you can send a link to that, I'm driving right now. I cannot take a picture of the QR code, but if you can send a link to the group, Dan, that would be awesome. And then my question is, considering you have so many challenges like operating these machines, how good was the support of the manufacturing company?
How good
Probably
was
for Chuck, yeah.
Do I have to answer that? So I think one of the challenges that we had with the robot is when it got turned on, one of the main computers fried, and so the simple answer, like my question was, well, what made that computer fry? Like, that's, when I put my farmer hat on, that was the question I would ask. NIO as a company said, don't worry about it, just put another computer on. And so, of course, another computer gets sent. We plugged that computer in, we fried that computer. And so then they said, well, there must have been something wrong with that computer, so let's send another one. So it was 3 computers in, and by then a month has gone by. And until they finally sent a technician down to take and we found out that one of the wiring connections on the robot, when it was unplugged from the GPS receiver, was twisted. It got twisted and it shorted out power in the ground, and that's what was causing all the problems. But by that point, 2 months had gone by, and so there is a disconnect between kind of what we had asked on a service request and what the company wanted to do. And these are one of the things that have to be resolved. Now, one of the nice things about NIO is that they did let us do some of the work ourselves, but this becomes a challenge. So I would argue that we had support from NIO. Maybe we didn't get the support that we should have gotten, which was some troubleshooting to say what would cause this to happen. And we all learned some things from this, both NIO as a company and ourselves, to start. A lot of times with engineers and with technicians, they always want to jump to the very, very difficult things, blame the computer, blame the hardware, instead of looking for the simple stuff. what is is there something actually very simple wrong with this robot that we could have fixed in 5 minutes if we had have, started there. I'm probably belaboring the point a little bit, but like the OEMs and the large manufacturers have a checklist. So when something like this happens, they will give you a checklist that says, step one, look at this, step two, look at this, step three, look at that. These new companies like NIO do not have those procedures in place, not yet. And that is, one of the reasons why we document our repairs and make these lists is to provide those checklists for users going forward. And I guess it's also why we're doing this kind of work. I'm not sure if that answers your question, Cesar, but
Oh
that's
yeah, that definitely answered my question. What one concern I might have is I'm not sure that's the case with this ones in particular, but sometimes these startups they rush to release their product in the market because they need to generate some sort of revenue to get more capital, and sometimes they're not ready. And
right.
especially I think in the farming sector, if this product made it to actual farms, actual commercial operations, and I think it would just burn the reputation pretty quickly.
Well, and I think that's we had a farmer actually request an Oreo robot for the spring, and I purposely didn't send them one for that very reason, is that I did not have 100% confidence that they could rely on it, or it's not that ready. The same goes with the Pixel 1 laser weeder. They actually build that as part of a full-scale robot called Robot One. It's about $1 million machine, and I was not convinced myself that machine was 100% ready. And so that's why we opted for a small scale trial of their technology. And as Ifex very, very gently noted, it needs some work before it is commercially ready.
Awesome.
Thanks for that, Chuck. Thanks for being responsible. I think we're all gonna benefit from that.
Thank you both. Ian and then Bridget.
But this conversation is a perfect example of why the Ag Robotics Working Group is so important to Ontario and beyond. And those are a couple of perfect case studies that should be written up to support those companies that are trying to come into this space. And the best example I use is you could have the best website ever and direct people to it before it's 100%. And if you fail them, trying to get them back is near impossible. And so being proactive up front and doing this type of thing should help other businesses that want to come into this space, right? And I think that's a fantastic value. So, we never want to see things not work right, but they're incredible learning experiences that will benefit everybody going forward. And then the other question that I have, not really a question, but just a comment. As an ex-weed guy from way back when, I'm always surprised on the identification of weeds in this robotic environment, that we're worrying about all the weeds to feed into these machines instead of just concentrating on the limited number of crops that we're going to be playing with, train the robots to do that, and then just get rid of anything that doesn't meet that crop requirement. And if anybody can answer that for me, I'd really appreciate it. Thanks.
So, I don't know. Yeah, like I put on the presentation, I was suggesting like having a pre-trained weed program, ID program, because currently there are lots of such programs available that is already kind of done a lot of work, which will make it easier to kind of just have any of those programs installed into the laser one, that because the work has been done there. So, but it's from the machine perspective, it will be easier for the machine to actually identify which crop it has to deal with, and then every other thing that is not a crop, it can, zap. So from the machine perspective, but that will require a learning program that will begin to train crops or target crops which are not or from what is available are not readily available at this time. So that was why a pre-trained weed ID program I suggested that.
Excellent. Bridget, go ahead.
I'm actually going to push mine to Chuck because I think Chuck, are you still talking with Ian about his second point? Because mine's about the validation checklist.
Sure.
So
Okay.
you go first.
Well, I was going to say that so some companies have tried that, Ian, doing the crop. And one of the challenges that they found is that a carrot, for example, looks different at every stage of its growth. And the number of images, like what Ifex was talking about, those change as well. And the other thing that the companies are working on is they're trying to figure out, and there's a comment there in the chat, is that if using, let's say, a laser to kill a weed, sometimes they need to know how much laser to put on that weed. And so, unfortunately, there's no easy answer. And I've just spent the last couple of days with Verdant Robotics out of California with their sharpshooter sprayer, and they talk about the same thing: identification of weeds, so they can figure out where to spray the chemical on that weed and how much chemical to put on that weed. So I think the argument could be made in either case. It's going to depend on the technology, and you know, it when I had our chats with Nexus back when they were doing their weeding tool, that was the approach that they had taken, was identify the crop. This is the crop in the row, and pull everything else out. It didn't go that well for them. They struggled with that because they didn't, as Ifex talks about, when there's a weed model, it's not just to identify the weed, it's also how to attack that weed based on how it grows, right? There's like a step 2. So you're not wrong. I think it's just, it takes people a lot smarter than the two of us to figure this out.
Awesome. Thanks, Chuck.
Another, that to add to Chuck's point, another conversation I have too as well is another, like more on spraying chemicals on weeds. It's like you might want to spray a product on a specific weed, but you don't want to spray on the other ones for whatever reason you can think of, Ian. And in that case, also makes sense. If you're just targeting, for example, one specific perennial weed that requires one systemic product, and you don't want to spray that on everything for whatever reason, but yeah, in that case, could justify.
See, look at that. Caesar's already jumping to level 10. Level 1 is just getting rid of the weeds. Now Caesar wants selective targeting. So we're going to level 10 right away. Good. That's how she goes.
Well, they were doing that, the Eco Robotics one. They have a couple, they only had done, I think, 2 or 3 weeds, and that's it. But they had that in mind. I think it's dog.
Yeah, I think you're right. I think you're right. Yeah.
I think you're right too, but it's just the scale thing. Like we're having trouble with the big sprayers doing that sort of selective thing, let alone the little ones that have to pack a bunch of different things on their back to skitter around the field. Anyways, it's all interesting stuff.
Bridget, pass it over to you.
Thanks, Dan. Chuck, I'm actually going to go back to your checklist mention. So we had last year started like an ag validation committee that was looking at like a checklist to essentially look at new technology that was coming in and like look at things like, do they have a user manual? Do they have tech support? Like that kind of thing. We kind of had paused that subcommittee because it didn't really seem like we were going anywhere based on where the industry was at with things. Is there, like with the checklist that you have, is there anywhere that the group could get together over the winter and like look at that, or have something that is available for startup companies that is a little bit more open for people, or is it specific to the robots that Hagerty has worked with?
I think we're open to expanding that and continuing that on. You know, it's an important piece. I think the first one that we're working through is the Oz robots. And that is, you know, our Ryden and others are working through that very, very closely. I think it'd be a good idea to expand that out. I don't see why we wouldn't, to other companies, other techs.
Okay, awesome. I will see if that group wants to regroup, and then I'll share, if it's not up on our website, I'll share what we had started for anybody that has feedback.
Excellent. Thanks, Bridget. All right. Thank you very much, everybody, for all your great questions, conversation. Thank you to Ezeh for the presentation today. Really appreciate you taking the time. Okay, and then so with that, we'll head over to the project updates for this week, and for that, I guess I'll throw it right back to Bridget.
I'm in the memory loss stage of life at the moment, so apologize, it has to get the right post-it note here. So just a few things. I'm going to keep mentioning it just so people don't forget about it, but we have opened up research proposals for growing season next year. So from now until December 31st, if you're interested in putting in a proposal for projects starting April 1st, 2026 and going till March 31st, 2026, there is funding available through the Agrobotics Working Group for projects that are ground truthing new technology in the fields. So I will throw the link to that in the chat again, but just as a reminder, it's there. There's also still a little bit of funding available left for this year. So even something like this checklist or that kind of thing, if you have any ideas, please contact us. Second mention is the subcommittees. So we will be sending an email out to people who were on the research subcommittee for last year to see if you're still interested in being a part of that. But for anybody new that is not aware of those committees, we do have a few out there. So we have the research subcommittee, we have an education subcommittee, which has not met yet, but that one's focused on like student engagement opportunities. We have the demo day subcommittee, which is looking at the events that we're doing this summer. And then the ag validation subcommittee, which was on hiatus for a while, but we can bring that one back. And then lastly, Ottawa Valley, if there's anybody from the Ottawa Valley area that would be interested in representing the working group at the Ottawa Valley Farm Show, we're most likely not going to have Dan or myself or my replacement there next March. But if there is anybody that has been joining the meetings that would like to represent us at that show, please reach out to Dan or myself directly. Those are my updates.
Yeah, awesome. Thanks, Bridget. Chuck, go ahead. Oh, you're muted.
Bridget just brought up student engagement, and I had the first high school reach out to me to enter the robotics competition. So I was very excited about that.
Excellent. We've had a few interested parties reaching out to us as well. We've been answering a few questions and whatnot, so we're excited to see where it goes.
It was what was interesting for that school because they are looking for farmers to talk with, and I gave them a list of 10 within 5 minutes of the high school, and they had no idea that there'd be that close. So I said the list is long. So
Excellent. Awesome. All right. Perfect. Thank you for the updates there, Bridget.
Just curious, Chuck, small town high school or big city high school?
small town high school.
Okay.
Yes, small town high school, which was nice to see.
I believe the other application though that has come through is a big city. I think it's Waterloo region. So it's good to see the small towns, but we do have some interest from larger schools as well.
Does Waterloo region count as big city now? Is that what's happened in my lifetime?
I mean, that's what we were going with, but
Perfect. With that, we'll head next into the roundtable discussion. So here's your opportunity to ask questions, problems, queries, thoughts, comments, anything of the sort crosses anyone's mind. Now's your platform to voice it. Waterloo region is now above 700,000.
So in the US, that would be a small town where everybody knows each other in the US.
Ian, go ahead.
So just the Ag Conference this year, I'm going to be doing a presentation I call iRobot, and it's sort of general to sort of get a field crop audience more engaged in robotics and stuff like that. And I'm going to use 3 examples of units that are on farm fields in Ontario and getting those people that are using them excited. So one is the 360 Rain with Hogendorn Dairy in Waterloo. The other one is Mark Richardson with the Roboti and the strip till and planting, and he just spent a huge amount of money to make a performance planter for that unit. So that's exciting that he would be doing that. And then the third one will be the Maze Runner, which is the Upside Robotics one, which I got a chance to look at a few weeks ago. And they have a 5th generation unit coming out next week, I believe, sometime. So hopefully I get to see that in the field before the end of the year. And I haven't asked the farmer that I talked to exactly whether he's interested yet, so I won't use his name, but I'm looking forward to that. If anybody has any ideas or anything for me on that, please reach out. I'd appreciate any comments.
Excellent. Thanks, Ian. Anybody else have anything?
Just future events. We've got Emily's Ag Enlightened event is October 23rd in Winnipeg. So you can Google that. Chuck and I'll be there. And then I think Kane has an event on the 22nd of October in Winnipeg as well, Garson. So if people are in town for Ag Enlightened, there's a bunch of networking opportunities.
Awesome. Thanks, Joe. Ainsley.
Yeah. Can you hear me?
Yep.
Here we go. I'll get my camera all lined up here. So yeah, just more of I probably should have gone in the previous section. Was just wanted to basically say, I don't know how many people were able to attend the Canadian Greenhouse conference that was on from Wednesday and Thursday. It was a really good session. I think they had at least 2 sessions with automation and robotics focus, and it's good to see that increasing, as well as just walking the show, the trade floor. There's so many more companies there representing with automating greenhouses, going from no touch to and low touch, as well as robotic and automation of various functions inside and the greenhouse and on the packing floor. So that was really good to see. I know there are a number of companies I saw there that not just from Holland, but we also saw Bold was there, and as well as some of the people putting forward their not things that we've been talking about. People have come in ag robotics. So I'm just trying to think of something that came to mind. There's just so much that you could not reasonably get to all of it, which was really good to see. And yeah, just wanted to give a report. Some other people that I know I've seen in this group there. So yeah, just thumbs up on that.
Awesome. Thanks for the insight on that, Ainsley. We appreciate it. Bridget.
I had one more thing to mention, which was we were looking at some dates for events in January, February. I know it's a busy time of year. It would be a 1-day event for ag tech and ag robotics startups. So just wanted to throw out Thursday, January 16th or Thursday, February 12th to see if anybody has any events that are already planned on those days and where those events are located.
Feb 12th might not work with the big Future Farm event that FCC puts on in Ottawa, and then there's a whole bunch of events wrapped around that, Bridget.
But so we'll just do Thursday, January 16th. See if anybody's got anything on that day.
So far, so good.
Bridget, sorry, what was the February date?
It was the 12th of February, but Joe mentioned that there's an event in Ottawa that FCC
That's that
runs.
one. Yeah, gotcha. Okay, yeah.
Okay. Perfect. Sounds like January 16th is the front runner on that. Thanks, Bridget. They're just going in order of when I saw things here. The Canadian Weed Science Society has their annual meeting coming up in Gatineau in November. Still time to submit titles to present on work that's happening in this working group at that annual meeting if it's of interest. The link for registration and title submission is there in the chat. That's from Brianne. Conrad, go ahead.
Yeah, we've been asked to look into cutting runners with laser on the strawberry farm. So basically, you all know we did the tabletops strawberry, and we're doing UV applications there. But the next step is we're looking into cutting the runners there. And so it seemed to be complex on many different levels. One, of course, is the identification of the runners. Secondly, is where to cut. It seemed to be a little bit complex, finding the right algorithm for that. And then, of course, the last thing is the laser itself. So if anybody has any kind of input or thoughts, suggestions, how we should, what we should keep in mind, what we should pay attention to, we greatly appreciate it. Or if anybody wants to contribute to the project, they'll be also welcome. So just putting that out there.
Excellent. Thanks, Conrad. Perfect. Did anybody else have any thoughts, questions, comments? No? Okay, as Ainsley mentioned a little earlier, there was the Canadian Greenhouse Conference earlier this week. Yesterday was the Canadian Robotics Council Symposium in Kingston. Not sure if did anybody happen to attend that. No, today is the Robotics and AI Symposium in Kingston as well. So maybe next week we might be able to get an update on that from somebody who was able to attend. Also already mentioned Ag Enlightened, as well as the Cane Networking Reception in Winnipeg coming up in just under 2 weeks there in October.
Thanks, Dan, for getting that posted. Come one, come all.
Absolutely, no
Free
problem.
food, and we'll buy everyone their first drink.
Hey, there you go.
That's worth a plane ticket to Winnipeg, hey?
Yeah, exactly. Debjani, go ahead.
Hi, this is a little different, a kind of request which I have. So I work with telemetry and sensor technology to measure the groundwater levels. And there's a lot of funding going on, and I think there are opportunities, but I'm trying to connect with conservation companies who would be applying for such funding. If I could get some reference, if you guys know people, I'm trying to connect with these various conservation agencies and kind of talk about the technology that I offer. I know it is not really connected to agriculture so much, robotics so much, but just a request, since we have various people in this group, so it's just a help I need. I'm trying to connect with conservation companies, agencies.
Well, thanks to Johnny.
Thanks. I mean, that's what. Yeah, I mean, I just thought I'll ask in this forum, since we have a lot of people here coming from different backgrounds. So I just wanted to check. Thank you.
Sure, absolutely. Thanks so much. If anybody has anything, you can reach out to Deb or to myself afterwards, and I can get connected. All right. Looks like the OPMC is in a few weeks. The focus of the event is on drone pest management. Yes, that's the Ontario Pest Management Conference. Everybody, I'm sure, saw an email earlier this week. They unfortunately lost one of their speakers, so they were looking for some support. I get the feeling that they've probably found somebody, so that's excellent. Thanks if anybody here helped with that, was on the helping side of that. Okay, excellent. We're just coming up to the end of our meeting here. Any last quick mentions before we head into this Thanksgiving long weekend? Beera USA is in 2 weeks. Thanks, Matt. Appreciate that. All right. Well, once again, thank you to our speaker for today. We really appreciate the time. Thanks for everyone for great questions and great conversation. Everybody have a happy, safe Thanksgiving weekend, and we will be back on the 17th, next Friday. Take care, everybody. Thanks so much.
Thank you.
See you everybody
Thank you,
later.
man.
Bye-bye.
Thank you.